Wöstmann, and in this short video I would like to present to you the results of a recent study that we published in NeuroImage, and the title of this paper was Orienting Auditory Attention in Time, Lateralized Alpha Power Reflects Spatiotemporal Filtering. So what does it mean? What did we do in this experiment? Well, the major idea was that we used an auditory spatial attention task that was established in previous studies, and we incorporated a temporal cue in this auditory spatial attention task. So the spatial attention task works as follows. Participants are presented simultaneously with spoken numbers to the left ear and to the right ear. And a spatial cue in the beginning of the trial indicates whether participants have to attend to the left or right side. And in the end of a trial, they are probed. So they see two numbers on a screen, and only one of these numbers appeared on the to be attended side. The other number did not appear at all. And participants have to indicate by button press which of the numbers appeared on the to be attended side. So that's the spatial attention task that we used in a very similar form also in previous experiments. And in this experiment, we incorporated a temporal cue. So this means in the beginning of the trial, participants were presented with these 5 blue bars on the screen. And in case all of these blue bars had the same height, were similar in height, the cue was neutral, so no number position was cued. But in 50% of the trials, the temporal cue was instructive, meaning that one bar was higher than the others, and then this number position would be cued, and this number position would also be probed most likely in the end. So in case of a valid temporal cue, for example, here number position 4 would be cued, and at number position 4 there also appeared the number 22 in the to be attended stream, and this number was then also probed in the end. And for an invalid cue, well, a number position would be cued, which was then not probed in the end. Behavioral results you can see here. So the proportion of correct answers of the participants. The behavioral results were not of major interest in this study. However, they are very important because they show that participants use the temporal cue. So participants performed best for valid temporal cues, and they performed significantly worse for invalid and neutral temporal cues. So this is important to know to prove that the paradigm works. Yes, participants used the temporal cues in this paradigm to guide their spatial attention. So on the neural level, this was an MEG, so magnetoencephalography study. We analyzed two major neurosignatures. The first signature was low-frequency inter-triphase coherence, which you see in A. So low-frequency inter-triphase coherence basically reflects, or is sought to reflect, the bottom-up encoding of the auditory stimulus. And quite unsurprisingly, for low-frequency ITPC, we see that it peaks, or it shows strongest activity at the onsets of individual numbers. Auditory numbers. And source localization of this low-frequency ITPC results in highest activity in the temporal lobes. So this is good indication that ITPC, low-frequency ITPC, reflects the bottom-up encoding of the auditory stimulus. In B, you see the hemispheric lateralization of alpha power, which is thought to be an index of the allocation of spatial attention. This is quite established in the literature. So in the time frequency plot, you see overall power, which was high in the alpha frequency band compared to a pre-stimulus baseline. So that's a typical pattern that we see in auditory attention paradigms, that alpha power increases during the trial, and then in the end of the trial, it decreases back to baseline. And in this source localization and on the topography, you can see the hemispheric lateralization of alpha power. So this is the difference between those trials where participants allocated their attention to the left versus right side. And you see a nice hemispheric lateralization of alpha power, which means that alpha power increases in the hemisphere ipsilateral to the focus of spatial attention, and it relatively decreases in the contralateral hemisphere. In C, you can see the hemispheric lateralization of alpha power for neutral temporal cue trials and for instructive temporal cue trials, which could either be valid or invalid, right? And you see this contrast here. First of all, you can see that for both conditions, alpha power lateralization was well above 0. So this means there was a significant hemispheric lateralization of alpha power if we just subtract the right hemisphere from the left hemisphere here. And there was no significant difference between instructive and neutral temporal Q trials in this overall hemispheric lateralization of alpha power. However, in this study, what was our main focus of interest and what was the most important neural measure was, of course, a time-resolved measure of how intertriphase coherence and alpha power would temporally evolve during the task as a function of participants having or not having temporal foreknowledge about the number position that would most likely be probed in the end. So the top row here shows a time-resolved analysis of intertriphase coherence, and you can see a nice 0.8 Hertz fluctuation of ITPC, which is basically the presentation rate of the individual numbers, so that's quite unsurprising. But what is important is that this 0.8 Hertz fluctuation does not significantly differ for a neutral versus instructive temporal cues. So whether participants have or don't have temporal foreknowledge has no impact on the temporal evolution of the low-frequency intertriphase coherence, which is thought to be a neural measure of auditory encoding. In the bottom row, you see a very similar analysis for the hemispheric lateralization of alpha power. So we can also plot the hemispheric lateralization of alpha power in a time-resolved way. And you can see that also this alpha power lateralization shows some fluctuations at a frequency of 0.8 Hertz. And interestingly, on the group level, this 0.8 Hertz peak in the spectrum was significantly enhanced for instructive versus neutral temporal cues. So indeed, this is the first indication that a temporal cue significantly affects a well-established neural measure of spatial attention, which is the hemispheric lateralization of alpha power, right? And in this 45-degree plot, you can see for all individual participants, we had 20 participants in this experiment, you can see the effect for individual participants, and you can see that most of these individual dots, they tend to fall above the diagonal, which means that the 0.8 Hertz amplitude was enhanced for instructive versus neutral temporal cues. Next, we tried to relate the neural results that I showed on the trial before, especially in terms of alpha power lateralization, to behavior. However, that's not very straightforward in this paradigm, because in this paradigm, as I explained before, the fact whether a single trial is valid or invalid in terms of a temporal cue only becomes clear in the very end when the probe screen is presented. But of course, the neural signals are recorded during a trial, before the probe. So this makes it a bit complicated to relate behavior to neural measures in this task. But we used a simple post-experiment questionnaire to ask participants to what extent they rated their the self-reported temporal cue benefit and temporal cue usage. And these two measures were significantly correlated to the 0.8 Hertz amplitude of the alpha power lateralization for instructive versus neutral temporal cues. So these two Spearman correlations, I think the left one was significant, the right one was close to significant, so that's some indication that the 0.8 Hertz fluctuation of alpha power lateralization relates to behavior. However, of course, this is a between subject analysis with 20 data points, and as we all know, we should not trust too much into these correlations with a small number of participants. So this is only anecdotal evidence, I would say, that there is a relationship between what we measure on the neural level and what our task was supposed to test, namely the use of temporal cues. Finally, we divided our individual trials in the experiment into individual segments, because we presented these 5 numbers, and of these 5 numbers in the temporal cue trials, or in those trials with an instructive temporal cue, only one number position was cued and the other number positions were uncued. So it makes sense to chop up the trial into individual segments and to contrast uncued and cued number positions. This is what we did in the final analysis, and we excluded the first and the last number position from this analysis because the first and the last number positions, due to design reasons, they were probed and queued less often than the intermediate number positions. So one problem in this analysis was that unqueued number positions were more frequent than queued number positions, of course, because only one number position was queued. So we had to account for that in a subsampling analysis. So this is why we subsampled very often, 10,000 times, the unqueued number positions, or the alpha lateralization for the unqueued number positions. This is what you see in the pink line, and you see the error band basically shows the 2.5th and the 97.5th percentiles. And for the queued number position, the alpha power lateralization was significantly different at the presentation time of the individual number, which was either queued or unqueued. So this indeed means that the modulation or the impact of a temporal queue on the hemispheric lateralization of alpha power is very temporally specific, because it shows up right at the moment in time when a number is presented. What might be a bit surprising is that the alpha power lateralization for queued number positions was more negative instead of more positive compared to unqueued number positions. However, it must be acknowledged that in this task the trials were very long, and it has been shown in previous experiments that the longer a trial lasts, the more alpha power lateralization goes back to zero and fluctuates basically around zero. And we consider it more important to look at the differences between the differences in alpha power lateralization between these relative up states and down states of the fluctuation of alpha power. And this modulation is clearly stronger in the blue line compared to the pink line. And the same result, if you want to look that up in the paper, was shown for queued versus neutral number positions. I omitted that here for simplicity, but a very similar plot resulted when we compared queued to neutral number positions. Okay, so finally, what can we conclude? Here's the conclusion section of our paper. I just pasted that here and highlighted the most important parts of that. So our studies show that the power of lateralized alpha oscillations, which is a well-established index of spatial attention, also signifies the distribution of attention in time. So that's a critical finding of this experiment, I think. And one possible interpretation of that is that temporal foreknowledge increases the temporal specificity of alpha power modulation, which we saw here, and that this might be a way to enhance spatiotemporal filtering. So basically filtering out of distractors and filtering in of to be attended relevant sensory stimuli. Okay, so thank you very much for your attention, and if you want to know more details, of course, feel free to read the complete paper.